Hey everyone, we're going to find the radius of convergence for the Maclaurin series for sine of x. Now we just showed that sine of x has Maclaurin series, the sum from 0 to infinity of -1 to the n plus 1 all over 2n plus 1 factorial x to the 2n plus 1. Right, and remember that that equals x over 1 factorial minus x cubed over 3 factorial plus x to the 5th over 5 factorial, etc., right? So now we want to find its interval of convergence and its radius of convergence. To find its radius and interval, if you wanted, of convergence, we're going to use the ratio test, which we always do when we have a power series involving factorials, and in general when we're finding radius and interval of convergence, right? So we take the limit as n approaches infinity of, now remember, we get to ignore that alternating -1 to the n plus 1, right, because we're taking the absolute value. So we'll have x to the 2n plus 1 plus 1 all over 2n plus 1 plus 1 factorial. And then we're going to divide this or multiply it by the reciprocal of just the nth term in general. Right, and then when we simplify this out, we're going to get x to the 2n plus 3 over x to the 2n plus 1 times 2n plus 1 factorial over 2n plus 3 factorial, right? Well, let's see what happens here, right? This is going to give us kind of an abusive notation right here. But all that's left over is the x squared. And all this cancels out except 2n plus 3 times 2n plus 2. So we're left with the limit as n approaches infinity. I'll write it down here. Of absolute value of x squared all over 2n plus 3 times 2n plus 2. And we know that regardless of what x equals, that gives us 0. So the interval of convergence, I know I didn't ask for this, but the interval of convergence is -infinity to infinity, and the radius of convergence is infinity. So what that means is that this Maclaurin series holds true for any value of x. You can plug any value of x in to sine of x or into this power series right here and get the exact same thing.